In this video, we'll be doing a problem that involves rate of change. The table below shows the rate, r, in miles per hour that a vehicle is traveling after t seconds. Notice t is given here in the top row, and r is the second row. The first thing that we're asked to do is plot the data and connect adjacent points with a line segment. So whenever you're asked to plot data, if you're given time as one of the variables, that will be the horizontal axis. So I've gone ahead and labeled my horizontal axis t and then marked off increments of multiples of 5. And then the other variable will be the vertical axis, in this case r. So I labeled my vertical axis r and then marked off intervals in increments of 10, my smallest 43, so I went down to 30, and my largest is 85, so I went up to 90. So if we plot these things, it's just going to be an estimate. At time 5, we had a rate of 57 miles per hour. So 55 would be halfway, 57 then will be about here. At 10, we had a rate of 74, which is a little less than half. 15 is 85, so 80 and then 90, halfway between 80 and 90. At 20, we have 84, so just a little bit below the previous one. At 25, we had a rate of 61, so 61, and then at 30, we had a rate of 43. Just a little bit below halfway. And then they wanted us to connect those with line segments. So if you wanted to do this on your calculator, we would want first to enter our data. So we'll hit stat, and then we'll need to edit. And then in list 1, we need to put in our times. So and then go over to list 2 and we'll enter our rates in list 2. Then we can quit out of that and go to stat plot, which is second y equals. We'll need to turn our plot on, so press enter to choose that. Press enter to choose on, and then this would just be the points, so we want to choose the option. So press enter to choose the option where we connect the points with line segments. And then list 1 was my time, so that'll be my horizontal axis or my X list. And then list 2 is my Y list, and then choose whatever mark. I can see this one better, so I'll choose that one. Right. Then we want to, if we hit graph at this point, we won't see our data because of the fact that this graph window goes from -10 to +10 and then on both the X and the Y axis. So we can do a zoom statistics, which is choice 9, I think. Yes. If we do a zoom stat, then the calculator will change the window for us. Now notice that was very much like the graph that we created. Right. The next thing that we're asked to do is to use the slope of each line segment to determine the interval when the vehicle's rate changed most rapidly. How did the rate change? Now what I'm going to do, I'm going to actually just find the slope from my data, since this is in numerical order, going from time equal 5 to time equal 10, we had, and this is my x variable, so let me just write my slope here. My change in x, my change in time is 5, and my change in the rate was 74 minus 57, which is 17. Doing the same thing going from 10 to 15, my change in the time again is 5. My change in the rate was 85, subtract 74, which is 11. And then for this one, my change in time is 5 again. My rate of change, 84, subtract 85, is a -1. And then for 20 to 25, my change in time is 5. My change in the rate is 61, subtract 84, which is -23. And then for this one, my change in the time is 5, and my rate change is 43, subtract 61, which is a -18. Now these slopes I can easily compare because the denominators are all the same. So all I have to do is look at the numerators, and I can see that the most rapid rate of change will be this one. So to answer our question, determine the interval. So the most rapid change is from time equal 20 to time equal 25. And they want to know how did the rate change. So since it was a negative rate of change, I would say decrease.